We are at the finish line, guys. Let's get our clothes into Unreal Engine. There are two things to consider before we export our models. First, the MetaHuman setup allows for a modular approach for attaching clothes to the character, so it makes sense to break our outfit into several pieces. The default slots in the MetaHuman blueprint are torso, legs and feet, but we can add as many additional components as we want. So let's go into edit mode and separate the pieces. I'll separate the pants as one piece, the stockings and shoes as one piece, and I'll also separate the cape. Concerning the cape, the second point to consider is the number of materials. In principle, we would want to have just one material for the whole thing. But since I would like to apply cloth physics to the cape, I need to be able to select only the cape for vertex painting. If the cape is attached to the vest, it would need to have a separate material slot, so I can paint the cloth weights on it without affecting the rest of the outfit. Since I already separated the cape from the outfit as a standalone piece, there is no need to create new materials and we can just proceed. An important thing to know is, when you export a skeletal mesh for Unreal, it needs to have the same name as the skeleton you are importing to. In our case, it has to be named root. Make sure it's not called root 001 or anything else. Otherwise you will get such an error message when you try to import your clothes into Unreal Engine. Let's also quickly rename the meshes so we know what is what when we come back to this project file anytime later. Right, let's export all outfit components now. Select the torso part and the skeleton and export it as an FBX. Choose selected objects and the armature and the mesh, and we can leave all other export settings on default. Just make sure that the Add Leaf Bones option is deactivated, otherwise Blender will add additional bones to the skeleton. Repeat the same for the other outfit components. Let's also export the helmet as an FBX, only the mesh, and the groom asset for the shoulder pad as an Alembic file. Set the scale to 100, frame start and end to 1, tick selected objects and visible objects, and which settings from your particle system you would like to use. I have covered these export options in more detail in chapter 4, by the way. Now open up your Unreal project, create a folder and drop the skeletal mesh FBX files that we just exported into the content browser. For the skeleton, select the MetaHuman skeleton and also check Create New Materials. Then click on Import All. I will delete the imported textures and import a clean set in a minute. In order to use UDIM textures in Unreal Engine, you need to enable virtual textures. Go to your project settings, search for virtual and check Enable Virtual Texture Support and Enable Virtual Texture on Texture Import. After restarting the engine, we can now import our textures. I like to keep things organized, so I create one folder for the materials and one for the textures. Now select only the 1001 texture maps of your clothes. I only need the base color, normal DirectX and the ORM texture maps. Then just drag them into the textures folder. You will then see a VT mark indicating that those are virtual textures. If you hover over a texture, you will see that Unreal indeed imported the whole set of UDIM files for each of the maps. Let's open the base color texture to check. Everything looks fine, I have all 7 texture maps here in this base color file. Now we can set up our material. Open up the material editor and drag and drop the texture maps here. What I like to do is create a few parameters which we can then use in the material instance. Add a multiply node by holding M and clicking in the editor, then hold S and click to create a scalar parameter. I will call this color brightness. Then I will make a parameter for the roughness intensity. Metallic doesn't need any adjustments. And to control the intensity of the normal map, we can add a node called flatten normal. And let's call the parameter normal flatness. Set the default value for all parameters to 1 and save. Let's now create a material instance and assign it to the material slots in the clothes meshes. To attach the outfit to the MetaHuman character, open up the blueprint, select the torso component and assign the torso part of the outfit. The same thing for the legs and feet. Now we have run out of slots for the clothes, but we still have our cape that we also want to attach to the character. To do that, click on Add and select the skeletal mesh component, give it a name and assign the cape to it. So far so good. The problem is that if I play an animation, the cape is not moving with the character. Well, this is easily fixed. The only thing we need to do is add the cape to the construction script. Duplicate the Enable Master Pose node, drop the cape component and connect everything. If we compile the blueprint, the cape is now attached to the body. Oh, and let's make the clothes shader double-sided so that we can see the cape from the front as well. Now we can also import the helmet, assign the material instance and then drop it into the blueprint. Drag it under the body component so it becomes a child component of the body. And now we can parent the helmet to the head bone, rotate it and move it into position. Let's play an animation to check. And voila, the helmet is firmly attached to the head. Let's have a look at the material instance by the way and adjust the parameters that we created. First of all, the outfit is way too glossy, so I'll set the roughness intensity to 4. Next we have no normals at all. Since we set the parameter for flatten normal to 1, all normal information is completely flattened, so let's set this to 0. With the brightness parameter you can make the outfit look darker or brighter. I will leave it on 1. And finally, let's also import the fur groom asset for the shoulder pad. Leave all settings on default and after the asset is imported, drop it into the level to check if its transforms are correct. Looks all fine, so let's actually add the groom to the character blueprint. Add a groom component and assign the fur to the groom asset slot. It is there, but it's not attached to the character yet. Creating a groom binding asset did not work in this case, but there is another way to attach the groom in the construction script. Adding a Enable Master Pose node as we did for the cape doesn't work since the groom is not a skeletal mesh. But we can add a node called Attach Component to Component. Our fur is the target and we can set the body as the parent. Next we can define which socket or bone of the body skeleton the fur should be attached to. For this, let's add a node called getSocketBoneName from the body skeleton and type the bone name here. If you are unsure how the bones are named, you can always check in the skeleton tree. If we compile the blueprint now, we see that the fur is moving, but it's way off, because its origin is not at its center. So let's quickly jump back to Blender, select the shoulder pad, set its origin to geometry, and then move it to the cursor at the world center. Now we can export the Alembic file again, let's call it fur_wc for world center, and import it in Unreal Engine. I will now duplicate the groom component in the blueprint, which is now called fur1, and I will set fur to invisible. Now I can assign the new world-centered fur asset to it and define the fur1 component as our target for the attach node. Let's compile and save, and boom! The fur is where it's supposed to be and works with all character animations. Wonderful! Now that everything is set up, let's check if our clothes skinning is holding up for different character animations. By the way, in case you didn't know, if you want to use the third-person animation assets for your MetaHuman, this is very easy to do in UE5. Go to Add Feature or Content Pack and add the third-person pack to your project. You will then have this folder here called Character, which contains the UE5 mannequins Manny and Quinn. Both of them use a skeleton called sk_mannequin. In your MetaHuman skeleton, you can now go to Asset Details, add a new compatible skeleton and select the sk_mannequin skeleton. Now all the animations are available for your MetaHuman as well. Alright, let's look at a few animations and check if we have any clipping issues. Everything looks fine except for the thighs in the front which clip through the clothes mesh. How can that be if everything worked fine in Blender? The reason for these clipping issues is that the MetaHuman body uses a post-process animation blueprint. This blueprint functions like the Preserve Volume option in Blender. It corrects the deformation of the body to achieve a more natural and realistic look. To be honest, I am not 100% sure why such clipping problems occur, since the vertex weights of the clothes are an exact match to the body. If you enable or disable the post-process blueprint, the corrections work for the clothes items as well. In any case, if you run into such issues, there are a couple of things you can do. Number 1, you can go back to Blender and move the problematic areas of the clothes mesh a bit further away from the body. In most cases, this solves the issue. Number 2, if the problem persists, you can also just hide these parts of the body. Find the areas you need to fix on the UV layout and paint a black and white mask, where the black areas would be masked out. Import the mask to Unreal, drop it in the body parent material, connect it to the opacity mask slot and set the blend mode to masked. Now the part of the body that was clipping through the clothes is invisible. I chose the second option for my character and now everything looks okay. In the next and final chapter of the clothes rigging pipeline, we will have a look at cloth and physics simulation in Unreal Engine.